Hello, so today we'd like to look at the uh, inequality questions from the homework, second part. So here we have the first question. Square root of x squared minus 6x plus 9 has to be less than or equal to 4 minus 2x. Now, you will realize that this has to be somewhat interesting because we have a square root within the perfect square. Notice if I have square root of a squared is in fact equal to absolute value of a. If I were to use that concept here, then this will simplify into square root of x minus 3 square, and further this becomes absolute value of x minus 3 is less than or equal to 4 minus 2x. Now you see x minus 3, whenever we have an absolute value, we have to realize that it will work in two different ways. When x equals 3, that's the borderline. So for example, when the value of x or values of x is greater than 3, then inside is positive. So therefore, absolute value will not do anything. So this portion would be having as if you have x minus 3 is less than 4 minus 2x. On the other hand, when the values of x is less than 3, then this will behave like absolute value will behave like a negative sign. So we're going to have negative x minus 3 less than or equal to 4 minus 2x. Let us try to calculate each section. First here, so we get negative x plus 3 has to be less than or equal to 4 minus 2x. Adding 2x, so therefore we have x plus subtracting 3, then we're going to have 1. So x has to be less than or equal to 1. You see, this one is our calculated value, and then all of them are within the given domain, so we are okay with it. And obviously, if you plug in 1, right side becomes 2, while the left side becomes 2, so they're equal to each other, so I can include value 1. How about on the right side? Here, we'll be getting 3x, which is less than or equal to 7. So x has to be less than or equal to 7 over 3. Now, then in this case, let's try to look at it. 7 over 3 is about 2.3, which is in fact, is it part of our domain, which is greater than 3? No. Since our calculated values are not part of our given interval which we are looking at, so therefore this one has to be rejected. Therefore our answer is, that's it. Alright, let's move on to the next question. How about here? You see the borderline will be 5 over 2. So before 5 over 2, this one absolute value works like a negative sign, so we're going to have negative 2x minus 5 is greater than x plus 1. On the other hand, after 5 over 2, absolute value will work like nothing else. So in fact, we're going to have 2x minus 5 is greater than x plus 1. Let's try to calculate that. Let's see what we end up getting. Negative 2x plus 5 has to be greater than x plus 1. By adding 2x, we get 3x. By subtracting 1, so we end up getting 4. So x has to be less than 4/3. You see, 4/3 is about 1.333, while this one is 2.5. So therefore, that is all of our calculated values are accepted in this domain or in this interval. So we end up having 4 over 3. Okay. All those values are accepted. How about on the right side? By subtracting x, we're going to have x. By adding 5, we're going to have 6. So x has to be greater than 6. And you know what? All these values are part of interval that which we are looking at. Obviously, if you have to plug in 6, it's not going to work. So this will be also open circle. And that's how we can do the second question. All right, let us look at number 3. Even though we have quadratic and then absolute value, but the idea is exactly the same. Look at the absolute value, and borderline seems to be 2. And then below 2, we get to have x squared plus 2x minus 3 is greater than negative of x minus 2. On the other hand, on the right side, we have x squared plus 2x minus 3 has to be greater than simply x minus 2. Then here, what do we end up getting? X squared plus 3x, because we are adding x, and subtracting 2 on each side, then we get minus 5 has to be greater than 0. Then here we have x would be equal to negative 3 plus or minus square root of 9 minus 4 times 8 times negative 5. In other words, this becomes 20 and 29 all over 2. So we have negative 3 plus or minus square root of 29 over 2. Those are the x values. Now, when you have negative 3 minus square root of 29 over 2, yes, that would be way below negative side. And in fact, how about negative 3 plus square root of 29 all over 2? Square root of 29 is a bit more than 5, so negative 3 plus a bit more than 5 would be 2 point something, divided by 2 would be 1 point something. So both of the values are in fact within our domain. Then what's going to be happening? Alright, so we're going to have negative 3 minus square root of 29 all over 2. And here we have negative 3 plus square root of 29 all over 2. And let's calculate the right side. Here we have, or we'll just finish up the left side first. Let's pick a value way below. So since this is negative 3, about negative 5 point something, so therefore the entire thing becomes negative 8 point something divided by 2, which is about negative 4 point something. And what if I were to use x equals negative 10? Then here we have 100 minus 20, so this left side becomes about 77. Or while the right side becomes simply 12, so this one is greater than this one, which satisfies the condition. First section is okay. How about between these two? This one was negative 4 point something. And here on the right side, we will end up having positive. So what if we have to set x equals 0? Then here we have right side becomes 2. Left side becomes negative number, and it wouldn't work. How about negative 3 plus square root of 2 over 2 to 2. This one I'm just going to use the calculator here for a second. So here we get negative 3 plus square root of 29 and then we're just going to divide that by 2. So 1.15 and 1.19. So then what if I have to plug in a number such as 1.5? Then here on the left side, we'll end up getting 1.5 squared plus 2 times 1.5 minus 3. Then you get 2.25. And on the right side, if you had to plug in 1.5, it would have been simply 0.5. So yes, left side portion actually is greater. So therefore, this section works. X equals 1.5, and it worked. These two sections were okay. Let us look at the right side and then see what happens here. By subtracting x from both sides, x squared minus x plus x, and then minus 1 has to be greater than 0. Then having x will be equal to -1 plus or minus square root of 1 square, which is 1, minus 4 times a times c is -1, so we're going to have plus 4 all over 2. Then we're going to have -1 plus or minus square root of 5 over 2. It looks like a golden ratio a little bit. Now, then -1 minus square root of 5 over 2 will be definitely negative number. So therefore that wouldn't apply to our interval, which is greater than 2. How about the second one? -1 plus radical 5 over 2. Radical 5 is about 2 point something. Subtracting 1, which will make 1 point something divided by 2, will be 1 point something. So both of the values will not be part of our interval right over here. So then, alright, then there is nothing that divides this right side of the interval. So here we get either everything will work out or none of them will work out. Just to argue that point, what if you had to plug in x equals 3? Then on the right side we'll end up getting 1. On the left side we'll end up getting 9 plus 6, which is 15, minus 3. So definitely works. Then just to check up on 2, if you had to plug in 2 here, then right side becomes 0, while left side becomes a positive number. So 2 also works. Then, what is our answer? So basically, we have to go to the left, and also we have to go to the right, all the way up. Now, here, to the left, if you have to plug in this value, left and right, and then let us try to see what we end up getting. To test that, I'm going to first plug in -3 minus square root of 29 and then divide by 2. So -4.19. I'm going to store that as maybe number A, value A. Alright, then on the left side what we end up getting is value A squared plus 2 times A minus 3. So on the left side we get 6.19. How about the right side? They will be equal to each other because absolute value of 4.19 minus 2 becomes -6.19, but absolute value makes them into positive. So they will be equal to each other, but that's not what we want. So therefore this has to be, left side has to be open circle. How about on the right side? This value, so -3 plus square root of 29 and then divided by 2. Now let's store that as maybe our b value. Alright, then our left side once again becomes b squared plus 2b minus 3. So we get 0.87-ish. And then on the right side, if you have to plug in 1.19 in this location, you will also get 0.807. So they will also be equal to each other. Then, since that's not what we want, we're going to have another open circle. And that becomes our final answer. I'll see you later. Bye-bye.